Hello everyone, welcome back. In this video I'll be making a fixture plate, figuring out how to get the registers to work. I'll be swapping out pins and instead using screws with a shoulder. And so for context, here's a plate that I made previously. It uses pins, brass pins, 16mm, fitting into 16mm holes. And it works pretty well, but it's just an extra step because the holes already exist, so I figured why not just use screws with a shoulder. And so the idea is that the shoulder will stick down through the aluminum and into the base plate itself. Here's a little sketch I did. Taking the existing part and just kind of turning it into a fixture plate instead. So just removing the holes I don't need and getting the operation ready for drilling the holes. I'm going to have the holes kind of drill down a little further just to be sure that I'm breaking through the bottom. And then the drilling operation and setting out to post. I'm not sure what I think about these vices. These are the Langmuir vices. And they have kind of like the spring-loaded jaw on the side nearest the camera. And when you tighten the jaw, they tend to push the back. So imagine the front being pulled down of the workpiece as it's being tightened. And so what that actually does, it's supposed to pull the part down, but what it actually does is it lifts the back of the part up, which is kind of annoying. That's why you saw me, as I tighten, I kind of give it a little dead blow to the back. I'm always afraid I'm gonna drop the probe when I'm taking it off. And that would really stink, because if you ever drop it on the probe end, then you gotta recalibrate it. Kind of hard to see, but I got a wrench that's on the collet, and it pops off right there. So as it lowers down, it's spring-loaded. I'll make a post about that at some point, and maybe I can give you guys the STL files for that. That's 3D printed. Okay, so running a spot drill pass. And I forgot to turn the chip clearing off, so it kind of dips down twice. So I will be using a spot drill, but I still do spot drilling because I've noticed that if I don't spot drill it, the stub drill will squeal a little bit, which means it's not quite centered. Yeah, so if I spot drill it, it doesn't squeal. It does a little squeal at first, but as it's drilling down, it doesn't, it sounds as it should as it's drilling down. And now I'm drilling the actual tap size. So that first drill size was the through hole size, which only goes about 10mm into the material. Maybe a little less, actually, maybe 5. And then this is the tap drill size, which goes through the material. And just hand power tapping the holes, M6 tap. So for fixtures, I tend to do that on the actual part I run the tapping end mill, or rather the threading end mill. And here's a close-up of the hole. So the larger end is the through, and that's for the shoulder on the bolt. And there's a little play, but it's really not bad at all. And once the threads engage, there's no play at all on the actual plate. Here's the final fixture plate and the work piece that will be running ops on above it. You can see there's multiple holes on the fixture plate. I actually made some oopsies there and had to re-drill a little bit to the right. And the reason for that is I forgot to tap the bottom hole with the proper size. So basically there are two holes at the top, and then there's the hole which is offset below that toward the center. It's a little bit offset to the right. And that hole needs to fit, the screw on the bottom actually is it's a M5, so that needs to go through an already threaded hole, which is a M6. So I didn't account for that, but I did here now. So here it is all fixtured up, and we're gonna run the first stop. Using a roughing end mill for the first cut. And this is it's kind of like a channel cut, although it goes the perimeter at first, and then it kind of channels in towards the front and cuts a profile. So I did this because I didn't want to remove all the other material, kind of like the typical way. Doing this because it's a little faster. The depth of cut is about 3 millimeters, I think. Not too aggressive because, you know, I'm on a fixture plate and there's 3 screws holding this thing down, so being somewhat conservative. But I can kind of tell by the sound, and it really wasn't vibrating at all, that I probably could go as far as deep as a 5 millimeter cut, and that would have been only like 3 passes, because this is it's a 15 millimeter plate, or rather part. And final profile passes. This is a 1/2 inch end mill, standard end mill. It's taking off about 1 millimeter. Again, not too aggressive. And I think it's doing about 3 passes. I gotta figure out this program a little better to... It always takes, it does like a finishing pass, even though it's doing the roughing operation, the first operation. A finishing pass, I have a separate op for that. But yeah, I gotta figure that out. Here is the finish pass. I wish the coolant was spraying down a little more so these chips weren't getting sucked back into the tool. But the finish ended up okay, so... And now chamfer pass. Alright, so plate worked okay. And now we're gonna flip the part on the plate. We don't have to re-indicate the part because those two securing screws are identical in terms so far as the distances from the corners of the part. And you'll notice I did not put the screw in that front hole, that offset front hole. And the reason is because that hole will be threaded in these next few ops. Running a M6 tap drill, well, a drill for tapping. And we got really close to these washers. You'll see when I do the chamfer pass how close things get. It gets really close. And now the threading end mill. I think it does about 6 passes or 5 to finish threads. I don't know what a good number is for an M6. I'm trying not to be too aggressive because it's a tiny little tool, so you want to go easy. RPMs are roughly 8,000, so it's maxed out. And now this front hole goes all the way through the part. And now the final chamfer pass. So this will do the perimeter, and then it'll hop in there and do the 3 holes. So the front threaded hole, and then get really close to do the back holes. That's really close. Almost looks like it hits, but I don't think it does. At least I didn't see any traces of it hitting when I got the part off, so I think it's okay. And here we are, gonna see how well these, this is from the last video, but since I've run a few ops now, just seeing how well our ball screw covers are doing. Looks like it let one chip in, but aside from that, the ball screws are completely clean. Taking the finished workpiece off now. It's always nice when you pull the part off, it's almost like suctioned onto the 2 flat surfaces. And here's the final part, and there's the other side. Came out good. And that's all for this video. See you guys in the next one.